Okay. My screen is visible, right? Oh no, sorry, I didn't. Just a minute. I hope it is visible now. Okay. So we discussed about Java architecture yesterday. What is Java architecture basically? So see, we also discussed the high level, what is high level programming, what is low level programming. So what we discussed yesterday is suppose a computer, okay, a computer. What is computer? Computer is an electronic device, right? So computer is an electronic device. Electronic device understands which language? It's only high voltage and low voltage, right? Only current and voltage it understands. So high voltage and low voltage. So what is high voltage and low voltage? So for any microprocessor or any computer, we used to provide a threshold voltage or supply, power supply, which would be 5 volt. Let's say 5 volt. Okay, so any signal is greater than this threshold voltage will be considered as 1, and any signal less than this 5 volt or threshold voltage will be considered as 0. Apart from these 0 and 1s, this is microprocessor by the way. You know, right? Microprocessor. In engineering days, we learned about microprocessor, microcontroller. So computer is, I mean, what is the internal structure of computer? It has a microprocessor in its central processing unit, right? So it can only process these zeros and ones or low voltage and high voltage, correct? Now what Java architecture says, now Java is a high level language or English like language which is understandable by human, right? So Java, suppose I am writing a Java code. What is that code? It's human understandable language, English like human understandable language, right? It's not the Hebrew for us. We can by reading the Java code we can at least understand what is this particular line is doing. That means it is human understandable language. So this human understandable language is called a high level language, okay, which is called high level language, HLL. Okay, and what your operating system or your computer understands, it's only zeros and ones. Okay, so this is called low level language. Okay, now the process, which process converts this high level language to low level language, is described in Java architecture. Okay, Java architecture. So it has compiler, it has interpreter. We'll discuss what is that. Okay, so if you are not understanding, please let me know. Okay, we have already covered it, but just reiterating it to go to next topic. Okay, so next topic is also related to this. We'll deep dive on each and every components of Java architecture. Okay, so see how this Java architecture works. Suppose you are writing a Java code here in .java file. Okay, Java code, you have written one Java code. Now this Java code, with the help of compiler, with the help of compiler, which will compile this .java file into a bytecode. Okay, now what is bytecode? Bytecode is a code which is neither understandable by human nor understandable by machine. What is bytecode? Bytecode is a intermediate code which is neither understandable by human nor understandable by machine. Okay, now this bytecode will be fed to JVM, okay, which is called Java Virtual Machine. We'll come to it. JVM, okay. This bytecode will be fed to JVM with the help of interpreter. Okay, interpreter. So what interpreter does? Interpreter reads this bytecode line by line and feed to the JVM. Now JVM is a virtual machine. What is virtual machine? Which is not actual or physical machine. Okay, virtual machine pops when you run your Java program on runtime. Okay, it's a virtual machine. You just imagine like some on top of some virtual environment your Java program will run. Okay, it's not actual, I mean not on top of physical system, but on a virtual, on top of a virtual machine or virtual system it will run. Okay, so JVM is that kind of virtual machine. You all I mean when you are working for a project, okay, working for a client, you already have encountered such thing. You have to work on virtual machine VMs, client VMs. So why so? Because client doesn't want you to work on your local system, okay, and that can create some security breaches, right? That is why they want you to work on their environment. They will create some virtual machines, and on top of that virtual machines you have to work, you have to test, you have to develop, you have to do everything, send emails, right? So that kind of virtual machine is inside our Java architecture also, okay. But that you will not get that JVM, or you will not understand the JVM is popped up and the code is running on top of that. It will be an internal process. Okay, it will be an internal process where your code will be fed, or your bytecode will be fed line by line to JVM, and JVM will execute the simply execute the code. Now for executing the code you need some libraries. Just like to make biryani in your kitchen, you need some masalas. So from where you get that masalas? You get that masalas from your shelf, right? All the masalas are at the same time, the same place. Okay, so those masalas are called libraries. Okay, here in Java terms it's libraries. Okay, and you need some gas oven or some chula kind of thing, which will be here a runtime environment. Okay, a runtime environment it will provide. Using this runtime environment and libraries, JVM will execute the program, okay, execute your bytecode, and it will show, or it will send it to your operating system, and operating system will show you the output, whatever output or whatever reporting tools you are using. Based on that, your operating system will send the output, or you will be seeing that output from there. Okay, so this JVM, okay, this JVM along with this runtime environment and all the libraries will be called JRE. Okay, JRE. What is JRE? Java Runtime Environment. Java Runtime Environment. Okay. Any question on this? So you understood, right? What is compiler, what is interpreter. So see, this architecture can produce many questions for the interview. What are those? Why Java is compiler as well as interpreted language? So you have to make your interviewer understand that this is where the compilation works, and this is where the interpretation works. Okay, that is why Java is called compiled as well as interpreted language. Okay, first question. Second question is, what is the function of JVM? Okay, that is second question. Third question could be, uh, what is JRE? We'll discuss in detail this JRE, JVM, and JDK. Okay, so we'll discuss it now. But this architecture is very important. Architecture will tell you everything about Java. Okay. Okay, let's go ahead and let's explore these components like JVM, JVM, JRE, and one more new term called JDK. Sorry, JDK, which is Java Development Kit. Okay, so one by one, let's deep dive. Okay, first let me go to JVM. Hmm. 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 Execution is not happening in operating on top of operating system. Okay, operating system shows the output, right? Suppose you are running one code in Eclipse. Okay, so Java code, actual Java code is running inside JVM, but what you are seeing inside in Eclipse, Eclipse is operating system dependent, right? Hmm. Eclipse is operating system dependent. Whatever console output you are seeing, it's actually you are getting from operating system, right? Suppose a Java application or Windows application you are seeing. Those Windows application, what is those? What are those Windows application? Windows applications are operating system's property, right? So those things, I mean, the operating system actually you use to show you the output, actual output, or getting input from you. Okay, understood? Okay, fine. So first thing, what is JVM? Very important interview question. JVM's full form is Java Virtual Machine. Java Virtual Machine. Okay, Java Virtual Machine. Java applications are called write once and run anywhere. We discussed yesterday that actual Java program runs on top of JVM. Okay, JVM. And whether you are suppose you have created your code in Mac machine. Okay, you have written your code or your Java code in Mac machine. The same code can be run in Linux. Same code can be run in Windows. Okay, why? Because it is not using, or Java program is not using the operating system or environment. It is using JVM to execute. OS independent, environment independent. That is why Java is a robust language. Okay, we covered it yesterday, but again, it's as we are discussing JVM, so these concepts these concepts are coming. Okay, so when you are running or when you are writing a code in Mac machine or Mac laptop, the same code can be ran in Linux, same code can be ran in Windows. Okay, because the code is not running on top of your operating system, it is running on top of your JVM. Okay, so Java is platform independent, but is JVM platform independent? Is JVM platform independent? No, JVM is not platform independent. JVM you have to have for the, I mean, it's a particular to a particular operating system. Suppose Mac, for Mac the JVM is different, for Linux JVM is different, for Windows JVMs are different, because the packages, if you I'll come to the installation of Java, then you will see there are different separate packages for separate operating systems. Okay, and JVM comes from those packages. Okay, so JVMs, if question arises, if JVM is operating independent to the operating system, the answer is no, JVM is not independent to the operating system, but your Java code is independent to the operating system. Okay, so what Java applications are called? Java applications are called write once, run anywhere, because of their ability to run a code on any platform. Okay, this is done because of JVM. The JVM is a virtual machine for executing Java programs. Simple. And JVM interprets the bytecodes into the machine. Okay, it interprets the bytecode into the machine level language. Okay, machine level language means zeros and ones, binary language. And what is bytecode? The compiled form of your Java code, which is neither readable to human nor readable to machine. Okay, bytecode is a compiled form of your Java code. So this is suppose Java, in Java architecture, this is your Java code, right? Java code. So first step, it will be compiled. It will be compiled. Okay, and it will generate a bytecode. Okay, in reality, dot Java codes are written in dot Java file. Okay, after it gets compiled, it will create a dot class file. Okay, dot class file. This dot class file is neither readable to human nor readable to machine. It's a garbage. For us it will come as garbage. Okay, garbage characters. Okay, and it will not, I mean, we can't open the file properly. Okay, now this is how the JVM works. Now, what is the internal structure of JVM? See, can I delete this all this thing? Okay, fine. Okay, so what is the input for the JVM? Input for the JVM is our bytecode. Bytecode, right? Now, what is bytecode and what is the file the bytecode will store? It's dot class file. Okay, now there will be a class loader. What class loader will do? Class loader is a subsystem of JVM which loads the dot class file into JVM. Okay, which loads the this dot class file into the JVM. So from here JVM conception starts. Okay, so in JVM there are separate areas. Okay, in JVM there are separate areas. Now dot class file will be will be compiled, not compiled actually, will be loaded into the JVM. Now there will be separate areas. Okay, there will be separate areas. First area is called method area. Okay, method area, where all the methods you have written, inside the class or inside the Java will be stored here in the method area. There will be one space called heap area or heap memory. Okay, in this heap memory, all the objects you have created will be stored here. Okay, this is for objects. This area is for methods. Okay, this area is for objects. There will be one stack area. So what is for stacks? Stacks are for variables and constants. Okay, variables and constants. And next thing is native stack. So I already discussed that to execute a Java code we need some libraries. To cook a biryani we need some masalas. Okay, so for these libraries or the common methods, okay, or native methods, not common methods, or the native, we call it as native methods, which are coming from the Java library itself. It's not external methods. Okay, so those methods will be stored in the native stack. Okay, all native methods. Okay, now this structure is actually called JVM memory. Okay, this is a structure of JVM memory. Now what is next? There will be some native interface. After your code is divided into separate memories or memory stacks, okay, your code will be fed to native interface. Okay, and this in this native interface, with the help of native libraries, which is in other word called JRE. Okay, and this will mix, means this, but these all libraries will be mixed here. Okay, and this will fed to another portion called execution engine. Okay, it is called execution engine. Okay, execution engine. Now this execution engine consists of two parts. Okay, two parts. One is JIT compiler, JIT, just in time compiler, and another one is garbage collection. Okay, and using I'll discuss this JIT compiler and garbage collection later. Okay, but with the help of this execution engine, the Java code, whatever you have written here, that code will be executed and will be transferred to the OS. The output will transfer to the OS. See if it is understandable. Don't go into the JIT and garbage collection, because I am going to discuss JIT and garbage collection right now. Apart from that, if you just let me know if you have understood this structure of JVM or not. Memories. memories, memory spaces. Hmm. Hmm. No, no. It is whatever methods are coming from Java runtime environment. Okay, those methods are actually storing inside that native stack. Okay, suppose there are some methods, right? Inbuilt methods could be there could be some inbuilt methods, Java inbuilt methods, right? So those inbuilt methods will be stored in the native stack, not in the method area. Method area will be user defined methods. Native stack will be internal methods. Okay, this heap area and stack area is very important here, because heap area is object area. Okay, so it's heap memory out of heap area out of memory. Always you get this kind of errors or exceptions in your Java programs, day-to-day Java program. Why so? Because when you create some object and do not close those object, then you will get the overflow of heap. Okay, overflow of heap. And stack, yes, yes. And variable and constants area are stack. Okay, stack area, always remember this. Okay, this is very important for interview, where your variables and constants getting stored. This is stack area. Okay, now coming to this portion, this is also very important. Execution engine. Can I delete this? Or you can just make a note, or I'm anyway recording the session, but I'm deleting it for this. So execution engine consists of two parts. One is JIT, or just in time compiler, and another one is garbage collection or garbage collector. So what is JIT? Just in time compiler. To see what is the process of whole compilation and interpretation. Your Java code will first compiled to bytecode, and next it will be interpreted to the machine code, right? This is the process, normal process. Now this just in time compiler Java is introduced to reduce the execution time. Okay, overall execution time. How? Java is saying that whatever methods you are writing, those doesn't need to be interpreted line by line. Okay, interpreted line by line. We do not need this interpretation. Methods will be further that bytecode. The bytecode will be directly compiled again. Okay, compiled again using this JIT compiler, and directly convert those bytecode to machine level language. Okay, so this is a shortcut method Java is providing to reduce the overall execution time, because the method you are writing, right, that method can be used in many section, many part of the program. Okay, or many part of the application. So every time it will interpret, every time it starts interpreting the methods, it will create a good amount of execution time. Okay, that is why method bodies will be compiled first and then again compiled to the machine level language. It will not be interpreted line by line to JVM. It will be compiled and again compiled using JIT, or just in time compiler to the JVM. Got it? So JIT means just in time compiler. Just in time compiler. Just in time compiler. See if it is clear or not. Any confusion on JIT? Clear, right? It's crystal clear. Okay, fine. Now next thing is what? Next thing is garbage collector. Garbage collector. What is garbage collector? Now we talked about one memory space in the JVM called heap. Right? We just talked about what is what is the function of heap? It stores the objects. It stores the objects. Now there could be several objects which are not getting used, so those objects will unnecessarily full this particular area. Correct? Unnecessarily those unused objects will create some more gathering on heap area. It will eat the space of heap area, because ultimately the heap area, stack area, limited memory, right? It actually using the computer memory or RAM. So heap area is limited. To clear, Java has a inbuilt functionality to clear heap area time by time. Okay, to clear heap area time by time. That a process is called garbage collection. That process is called garbage collection. What is garbage collection? Garbage collection, using garbage collection, Java clears the heap memory. How? It clears the unused or untracked objects stored in the heap memory. Okay. Now, this is a time by time Java's internal structure, okay? Java's internal operation. We can suggest that please execute that garbage collection using this GB method. But it is not, whether we are calling that GB method, it's not going to clear the heap memory. We are just suggesting JVM to, or we are just suggesting Java to run the to run the garbage collection. But it is not, it is not in our hand to clear the heap memory. It is Java's internal responsibility or internal operation to clear the heap memory. We can suggest. Now this is up to Java, or up to Java architecture, or Java Java library, or JVM, whether to run garbage collection or not. Got it? Any kind of confusion? Itself decides. It has no particular timing. It has no particular structure. Whenever JVM feels that my heap memory may exceed, it will run garbage collection. It's all internal decision. Right. It's nothing in our hand, but it's Java's own decision to run garbage collection. We can suggest please run garbage collection by executing the garbage collection method, GB method. Okay, GB method. But Yes, only unused. Hmm. See, see, there is a way of declaring a object. Okay, so declaration is like this. Suppose everything works on class and object. Okay, in Java, this is suppose class. This is class one. Okay, and under that, to use the class one fields like methods, like variables, you have to inside public static void main, you have to create the object of the class one. So how you create the class one object? See, this class one, this is obj equal to new class one. Okay, this is the way we create object. Now suppose this new keyword actually creates the object, and this object is getting stored in obj. Without this is called object variable. Without this object variable, we cannot use the object. Okay, and so it is not necessary to create, object variable to create an object can be created without any object variable also. Okay, but it is unusable. So any object, or any object is detached with the object variable. Any object is detached with the object variable will be declared as unuseful. Okay, those unuseful or unused objects will be cleared by garbage collection. Now this can be if you are not doing these kind of operations purposefully. Okay, purposely you are not doing it, but internally, whether you are calling some other functions, other methods, other third party libraries, that can do that. Because if you are calling third party libraries, it's not in your hand whether it has created any new object without any object variable or not. Hmm? So with that thing, garbage collection is always needed. Okay, to clear out the heap memory. And if it is not unused, if it is mapped with some object variable, then it will not delete, it will not touch, Java will not touch. Okay, and that is why if you are not closing, if you are all using, but if you are not closing any object, then heap memory will exit. Okay, and you will get out of memory issue. Okay, now clear, right? So the term is, we have already declared, discussed what is JVM. Now what is JRE? JRE is the Java runtime environment. Okay, Java runtime environment. Java runtime environment. Okay, now what Java runtime environment does? Java runtime environments actually provides the provision of JVM. Okay, JVM creates on from Java runtime environment. Okay, JVM gets created using Java runtime environment. This is the actual all the softwares are actually uh, all the libraries are kept inside this Java runtime environment. Okay, so JVM is creation of JVM is one of the responsibility of Java runtime environment. For execution, supplying the libraries. Okay, for execution, supplying the libraries, another responsibility. Okay, and provide a runtime environment. Provide a runtime environment. Okay, so these are the responsibility of Java runtime environment. Okay, now if we diagrammatically see the actual structure of everything, right, what we learned so far. So JRE consists of what? JVM, and the libraries, because JRE is providing JVM, JRE is providing libraries, right? Now to execute the program along with the JRE, we need some development tools. Development tools. Development tools are basically the compiler, interpreter, etc. etc. There are many. So this JRE and development tool will execute a Java program, and this whole package will be called JDK. What is JDK? J for Java, D for development, and K for kit. Java Development Kit, or JDK. JDK consists of JRE and developers tool or development tools. What are the development tools? It's compiler, it's interpreter, and etc. etc. and executors. Clear? Any confusion? Nirmal joined, right? Nirmal, Vanilla, any question on this? It's clear, right? Crystal clear. Please let me know if it is not crystal clear. Okay, so here the Java architecture ends. Okay, now we will okay, one thing, right now Java 24 is the latest version of Java is Java 24. Okay, I forgot to mention, from Java 11 they have decommissioned this JRE. Okay, they have decommissioned this JRE. Then where these JRE things, JVMs are getting situated, those JRE and JVM, those JRE libraries and everything is getting situated in the development tool itself. Okay, inside bin folder. Okay, initially, if you see Java 8, Java 9, so there was a separate folder called JRE, and there was another thing, JDK. Okay, now mandatorily you have to install JDK. Okay, not JRE. JRE is no more needed from latest version of Java. Okay, all the libraries and everything is coming inside this development tools folder. Okay, so JDK consists of only this development tools folder. Okay, with all the necessary softwares and libraries. Okay. Okay, fine. Now, so what are the operating systems you are using? All are using Windows? Okay, and what about Vanilla and Nirmal? Okay, fine. Then Windows, installation of Java is straightforward. Okay, so see. So you have to go to Java or download Java. Okay, download, open JDK. Okay, open JDK. Now go to the Oracle site. Or rather, download Java. Java downloads oracle.com. Okay, so from here uh, go for JDK 17. Okay, why JDK 17? JDK 17 is LTS. LTS means long term support. Okay, JDK 17 is LTS or long term support. Okay, so here if you see there are three tabs. I was saying, right, Java is platform independent, but JVM is not platform independent. Why? Because you have to install the packages based on your OS, and JVM is coming from those libraries, okay, those packages. So for Linux, for Mac OS, for Windows, okay. So for Windows, you download this one, this exe file, okay, 64 installer exe file. And it is after I mean, are you doing with me? Yes, yes, please do it. Yeah. Anyone can share her screen. That will be. Okay. Actually, it's not visible. I mean, no. Entire screen. You share entire screen. Okay. No. Mm, ye- Now it is loading. Yes, yes, yes. Okay. So JDK 17 and install that exe file. Yeah. No, you are for which OS you are doing? It is for Linux, so you have to select the Windows. Hmm. Hmm. Then download the exe file. Yeah, second one. Hmm. Yeah, just let it. I mean, it will take some time to download. Let it be downloaded first, then we'll go ahead. No, it's still downloading. See the you can see this uh, the progress, right? Progress. Others please follow, otherwise. Okay, it's done, I think. Double click, simple double click. Yes, yes, yes. Okay, that installer is not, I mean, I'm not able to see that installer process. It's not visible. Okay, next. Click on next. Click on next. Simple. All should be next. I mean, there is nothing. Okay. Yes, next steps. It's just documentation you will get, but Java installation is completed. Okay, just if you want, you can read out this documentation. Otherwise, you can close the installer. No, not there. If you see below, installer is opened. Below in the taskbar, you can close this installer, right? So your Java is installed now. Now you have to set up the path. Okay. Now can you go to program files, users program files, and then Java. Go to C, local disk C, then users. Okay. Program program file 86. Go first program file 86. Then you will see if Java folder is there. Is there any Java folder here? Otherwise, go to normal program files. Click on that. Now JDK 17. Okay. Just copy this path. Just copy it. Now go to your search. I mean that Windows search, and no, not there in the lower. I mean in the taskbar. Okay. Environment variable for your account. Just type environment variable. Edit environment variable. The second option. Yes, yes, yes. Open it. Okay. So here, just create a new. Click on new. In variable name, write Java underscore home, all in capital. All in capital, Java underscore home. Right. And whatever you have copied, just put that in the value. Okay. Now click on OK. Now next thing, click on path. If you see, there is a path variable. Click and edit. Click on edit. Okay. Now here, click on new. Okay. Now here, percent Java home, only capital, Java underscore home. Again percent. Okay. Now front slash, just like what is written in above line, right? The front slash, that is backslash, front. Bin, bin, small bin, bin folder. Okay, that's it. Click on OK. Click on OK. That's it. Your Java is installed now. Now open a command prompt. CMD, search CMD. CMD. uh, Java, write Java, small letter Java, space, hyphen, version, 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 not space, VERSION, version. Enter. Your Java things should be displayed. See, your Java is installed correctly. Okay. Now, everyone is done. Your hmm. Yes, if you are facing any problem, you can share. I mean, just share your screen. Mm, in the lower portion where this close button means cut the call button is there, upper arrow mark is there. So click on that upper arrow mark and go to that entire screen, share entire screen tab, and share it. Okay. Till what I mean, what did you do till now? 17, Java 17, right? Okay. So JDK 17, you just copy the path of JDK 17. Okay. Right. Till JDK 17, you just copy. And make sure that inside JDK 17 there is a bin folder. Just go there. uh, Bin folder is there, right? So copy the path till JDK 17. Okay, now go and search for edit environment variables for your account. Edit environment. No, don't go to bin folder. Bin folder is not there, not needed. Only copy the path till JDK 17. Okay, and then go and search for edit environment variable for your account in the Windows search. Windows search means in the taskbar. Edit environment variable for your account. Not at the top. Okay, just below you have one Windows search, right? No, not file explorer. It's uh, in the below section, right? In the below section. Whoever who just shared the screen, can you please share again? I think Nirmal, right? So can you just share again and show her how where to search that. Yes. Right. Java. JDK 17 and copy the path. Copy the path of JDK 17. Er, huh. Then go to search. No, don't go to bin. Don't go to bin. Go to search. Uh-huh. Edit environment variable for your account. Uh, Edit environment variable for your account. There are two options. The second option. Second option. Edit environment variables for your account. Click there. Yes, yes. Open it. Uh, Click on new. Click and Java underscore home. uh, Java underscore home. And click on OK. uh, just cancel and after that just click on path and click on edit button. Edit. And here just type this percent java percent slash bin. Whatever Java home you have set, na, we are just setting up or we are just declaring the bin path, bin folder we have, right? So what I said, all the softwares are in bin folder right now. So we have to set the path of bin. Okay, that is why Java home slash bin. Click on OK. Click on OK. And if it is everything is fine, then go to command prompt. Command prompt. And type Java space small, all small, space hyphen version. Enter. What are you getting? It's Java 17. Everything is getting, right? Right. So that means your Java is now installed. Okay, Java is now installed. Okay, what about vanilla? Okay. No, latest version is okay. Not a problem. Not a problem. Okay. Now let me share my screen. Okay, fine. So till now what we did, till now we have installed Java, right? We have installed Java. Java installation is done. Okay, now what? Java program we have to write, correct? Now to write Java program, we need some text editor. Text editor. Text editor. Now this text editor could be anything. It could be your notepad, where you will be writing codes. Okay, notepad. It could be your notepad plus. Okay, it could be some professional text editor or code editor. Okay, professional text editor or code editor, such as it could be Eclipse. Okay, it could be VS Code, Visual Studio Code. Okay, it could be IntelliJ IDEA, and many more. Okay, many options are there which supports Java. Okay, but what we'll use, see, we can use Eclipse. So Eclipse means, why we need it? Because it provides some facilities to write the code. How? It provides automatic orientation of the code. Okay, automatic orientation of the code. It provides automatic creation of the class and objects. Okay, it provides some suggestions, right? Suggestions based on the, if you have Java installed on your system, then using those internally, this kind of text editors, this kind of IDE, integrated development environments. These are called integrated development environments. Okay, these kind of text editors actually reads those libraries and suggest as per your code, so that you do not have to write each and everything on your own. Okay, so we could use Eclipse, but right now Eclipse is bit old. Okay, so I do not prefer Eclipse. We could use IntelliJ IDEA, but IntelliJ IDEA's free version is very problematic in the sense, it hangs, it crashes, and it takes a very ample amount of space, memory space, if you install IntelliJ in your system. Okay, it's not lightweight kind of thing. So only option I see which is better among all of these things, right, is VS Code or Visual Studio Code. So we have to install Visual Studio Code. Okay, so first we have to download Visual Studio Code. Java we have installed, now we have to install Visual Studio Code. So download, just type in Google, download Visual Studio Code. Okay, and go this code.visualstudio.com. Okay, now again someone can share her screen, so that I can direct, because I am using Mac, so the installation process of Mac is a bit different. Yeah, sure. Yes, again, okay. So Visual Studio Code, visualstudio.com. Yes, go there. Okay, so you are seeing there are three options: Windows. Okay, there are for Linux, Debian, Ubuntu, Red Hat, and one is for Mac. So what we have to do is Windows, we have to select. Okay, Windows 10 and 11. Okay, and at the top corner you have this download option. Just click on that. Okay, is it downloading or what? Okay, it's downloading. Correct. So again click on that VS Code, I mean exe file, and installation process would be same. So I accept the agreement. Click on next. Okay, click on next. No, don't browse, just click on next, it will be automatically okay. Wait, don't create a start. Yes, yes, Windows 10 11. You are using 10 11, right? Because below that it's already decommissioned. uh, hmm. And you got the file, right? Exe file. Hmm. uh, so just wait, let her things also download it, then we'll go. After download is complete, just double click on the exe file. Just wait for some time. Okay, wait. First let the download be completed, otherwise everything will be, corrupted version. You'll face many problems. Yes. uh, just click on next. Now you are in this same page, right? Same window. Route. Now click on next. Okay, now here check all the options, create desktop icon, add open with code, action Windows Explorer. Okay, now click on next. Okay, then install. That's it. Yes, yes, install. Finish. Okay, uh, that's it. You are done. You are done. Okay, just close it right now, just close it. Okay, fine. Now everything is done. Let me share my screen. Okay. My screen is visible, right? So what you do, go to your file explorer. Okay, maybe somewhere in D drive or C drive, whatever, wherever you want, you create one new folder. Okay, new folder. Name something. Okay, okay, now go into inside that folder, just right click. You will get, I am not getting that option because it's different ways, but you will get open with code. with VS Code, open with code. Just click on that open with code. Your VS Code will be launched. Can just go inside this particular folder. What folder? Which folder you have just created? Right. Go inside that folder. Folder is empty. Now right click here, you will get one option called open with code. Yes. Click on that open with code. You will your VS Code will be launched with blank everything. Yes, I trust the authors. All this you just do. Okay. And close the welcome screen. Close the welcome screen. Let me open my VS Code from here. Open folders. So you are getting this kind of view, right? This kind of view. So close the welcome folder. Okay. Now here, if you hover this August batch, just like I am hovering, you will get these buttons. This is for creating new file. This is for creating new folder. Okay, this is reloading the refresh the explorer. Okay, so create a new file. Okay, create a new file. Click on new file. So file name would be my first program dot java. My first program dot java, and then enter. You will get to see that please install, the options for please install the recommended plugins. So install all these plugins. If you are getting some options, please install all these plugins. Click on install. Right. Extensions of plugins. Yes, installing. It should be installed. One by one, it will be installed. All the recommended extensions. No, install JDK is not required. Okay, can you share your screen so that I can see? Okay, so what are you getting? Yeah, accept. Install JDK is not required because we have already installed JDK, right? So just close this welcome screen. Welcome screen, yeah. Close that welcome screen. Okay. Close the welcome screen. it's not required. So if you see, there is an opening Java project. You are seeing the opening Java project is already working. So its Java project is opening. Okay. Now if all the process just now for Nirmal, all the process has stopped. Okay. So you can start writing your code. Okay. Uh, just type CLASS class. Just click on first option. See all the boilerplates you got. Okay. Now inside that, just write main, main, main. Only first click on first option. So public static void main you got. Okay. Now you want to print your first, you want to run your first program. Okay. Just to print hello world. Okay. Just print hello world or my name is Nirmal. Okay. So how to do that? How to print something in the console? System.out.println, the same second option, system.out.println. It has a shortcut called sysout. Okay, sysout. So if you sysout, then just here, let me share my screen. Okay, stopped sharing. Anyway, I'm sharing my screen. Okay, this is my blank class. Okay, we'll create a class here. We'll create main method here. Right now, sysout system.out.println will print something in our console. Okay. Now, as a string, inside a double quote, you just put my name is Nirmal or whatever. My name is whoever is using, just print your name. Okay, I am printing my name. My name is Suvam. Okay, now see, you will get this run and debug option link. Are you getting these two, run and debug, just above your main method? Everyone is so quiet. Why? Nirmal dropped or what? Rupali, you are getting, right? Okay, fine. Java file you have created, right? Java file. Okay, fine. This is done or what? Okay, fine. Let me create this file again. Or you have created this file. The view you got, right? So what you have to do? Okay, fine. So this is how you have, right? Blank file. Okay. Right here, class CLASS class. You will get these two options, one box and another one. Click on this first. So it will create this class structure. Correct? It will create this structure. Now write down main. You will get this public static void main or this main. Okay, the box first. Anyway, second one is also same, public static void main is there. Okay, now to run every program we need this main method. Why? I'll tell you. Okay, let Nirmal join and then we'll tell you why this structure is needed. Okay, so inside that you want to run your first program. How to do that? Suppose you want to print your name. To print your name or anything in console you need one command. Just put sys out. Sys out, sysout. This is a shortcut of system.out.println. Okay, click on system.out.println. Okay, inside that, within double quote, you have to put whatever you want to print. That is, my name is Suam. Okay, my name is Suam. Now you are getting this run and debug options from in just above this main method. Yes, so click on this run link. See, we are getting this my name is Suam string. Are you using office laptop or something like that? Allow, you are getting, are you getting allow option? Allow. This is called console or terminal. In Visual Studio Code, we'll call it as terminal. Okay, but when it is when you are using some other things like Eclipse, right? That is called console. Same thing. Okay, fine. Did Rupali join? Yes. Uh, no, if you want to get that, you will get it. If any problem occurs, the problem tab will automatically create it. Okay. If you have some output things, output is not, it's not output basically. Output means some other things. Okay. Then output tab will automatically be created. No worries. Okay. Did Rupali join or did sorry, Nirmal? Okay. Okay, so you clicked on this run options, right? Run option. This one that is also fine, but if you want to run any specific method, then this link is useful. Run. So congratulations, you have written your first Java program. So now the structure, right? So if you see the first line, just ignore these lines. Okay, these lines are just comments. These lines are not compilable codes. These just comments. Okay, comments means we write some codes or we write some sentences to make users or any other developer understands what this particular code for. Those are called comments. Okay, so these are comments. Okay, so first line is compilable line is public class my first program. So I told you, right? We have already discussed to create any Java program or to use any Java components. First thing what we need to do is we have to create a class, right? What is class? A class is a pro forma. How it is? Okay, let's say a railway reservation, example of railway reservation. what you do in a railway reservation system, not online but in offline. If you go to the counter, what you will get, you will get a form, reservation form, right? That reservation form is a blank form. Okay, reservation form is a blank form. On that reservation form you will get from, okay, from location, and to location, that means destination, date of journey, preferable trains, preferable berth, what camera you want to book, right? I mean, it should be I mean, it could be your first class, it could be first AC, second AC, third AC, normal sleeper class. So those options you have to choose, right? See, so what you will get is, you will get one form. Okay, now you all three, okay, went to some station counter, and went for some reservation to go to your village. Okay, suppose this is one form is taken by Rupali, right? One form is taken by Vanilla, and another form is taken by Nirmal. Okay, you all three got the same form, only difference will be the name of the passenger will be different. Here it is Rupali, here it is Vanilla, here it is Nirmal, right? And you have manipulated your from location to location, date of journey based on your requirement. Vanilla has manipulated her name and from location to location, date of journey, right? And Nirmal has also entered from location to location and date of journey different. So what you did, I mean, you used this pro forma, which is a form, railway reservation form. You use this pro forma or the fields to create your own objects. The form you have created, the form after filling up what you have created, cannot be used by others, right? The Rupali's form cannot be used by other people. Vanilla's form cannot be used by other people. Nirmal's form cannot be used by other people. So Nirmal has created her object, Vanilla has created her object, Rupali has created her object with the use of these predefined pro forma. So this predefined pro forma will be termed as a class, and these are specific to the people, right? Things will be which are actually manipulated things will be called as object. Okay, object. It is object of Vanilla. This is object of Nirmal. See, if you have understood this class and object conception. Let me give you another example. Let's say you have a car, okay, cars. So what you have inside a car? You have 4 wheels, correct? Mandatory, right? 4 wheels. Otherwise, it would not be car. It could be auto rickshaw, or it could be cycle. It could be truck. But for car, mandatorily there would be some 4 wheels, 1 steering, at least 4 to 5 seats, based on anything. I mean, there could be some seats and one engine will be there. Okay, these are the basic feature, right? So using this basic feature, Tata Nano has created his car, Tata Nano. Using this basic feature, Alto has created its own car. Using the basic feature, BMW has created the same thing. Using the basic feature, Audi has created its own car. The cars may be different based on its price range, based on its engine power, based on its mileage. But if you see the basic things, basic fields, 4 wheels, 1 engine, 1 steering, 1 gear, there are some seats, will be common for all the things. So these will be called here the objects. Okay, objects. Okay, and this is called class. Car is a class. Alto, Nano, BMW, Audi, all are objects of car class. Okay, the same way we have created one class. What is class? Class is a form or pro forma. Okay, predefined pro forma, predefined set of rules or pro forma. Okay, now here I can use any variable. Int a equal to 10, not a b c d variable name is not standard, so from starting we'll do some standard practice. So variable name should be a proper name. Okay, so int age equal to 10. Let's say int salary, let's say 1000. Okay, string address equal to there could be, I mean, all Pune. Okay, address is Pune. So these are all fields we have created, just like the fields we had in our railway forms, like form location, to location, all these things, right? So here we have created our int age, int salary, string address, okay, on our own, for our own purpose. Okay, now if you want to directly access this, I just want to print this age, is not possible. See, you are getting one error. Cannot make a static reference to the non-static field. Mainly, you cannot call or you cannot access these normal fields from static method. From main method. And what is main method? I forgot. What is main method? Why we are writing this syntax? This public static void main is the starting point of any program. Whatever you are writing, whatever methods you are writing, you have to call everything from this main method. Okay, one by one, because Java or JVM will look for this keyword, particular keyword, public static void main, string argument, and this. Okay, this is a fixed keyword. It cannot be changed. Okay, this is written in JVM. JVM is also a Java program, right? They have created it separately, but this is also a Java program. So inside JVM, they have created this particular keyword so that it can find out this keyword for any class, okay, and start execution from this point. So starts, I mean, execution starts from main method only. Got it? Why we need this particular keyword? Because it is mentioned in the JVM and it is Java's own property. So to run any main method, to run any Java program, you mandatorily need any main method. Okay. Now we cannot access any of these fields inside this main method. We have to access, right? Otherwise execution will not happen. The executable things will be only this public static void main. Okay, we have to call all of this here. So how to call it? We have to call it using an object. How to create object? I showed you. So first thing is my class, I mean the class name. Okay, class name. Then object variable. Okay, object variable. Anything can be there. Then the keyword new. Okay, this. Okay, my first program is a class name. You have to mention this class name. This object variable will hold these object. Okay, new keyword actually creates the object. Here we can write new keyword creates the object of class. Object means what? Object of class. Okay, now using this object you can access these fields. See, obj.age. The same way you can do for obj.salary. Okay, same way you can do obj.address. Okay. Program names, there is nothing called program names. This is file name, and file name should be same as this class name. Okay, now see, look at this particular line. This is very important. How I am creating object? I am creating object using class name, then an object variable, then this new my program. Okay, now this is the actual object. Okay, now if I am only using this, okay, now am I getting any error in this line? No, because new my first program is actually creating the object, but that object is not useful. Okay, that object is not useful. These kind of objects will go to heap memory and will be eligible for garbage collection. So always do create your objects using with the reference of a object variable. My first program, obj is the object variable which has a type of my first program, which is class type, and this is the object. What is that? What is obj is doing? Obj is actually holding the object. Obj is holding the object. It is not object, but it is holding the object. Obj is just a variable. Okay, we will see what is variable, what is constant, what is a primitive things. We will see. See if you have understood or not. Understood, right? And if you run it, you will get all the data, like age is 10, salary is 1000, address is Pune, right? If you want to make some changes, right, some put some, if you want to put some messages, some messages over here, right? Like here, my age is 10. Here, my salary is 1000. Then my address is this. So if you run, this data will be printed along with these strings, okay, these sentences. See, my age is 10, my salary is 1000, my address is Pune. Got it? Any confusion? Yes. Class name should be same as the file name. Then you have to create multiple files, right? You have to create multiple files. That is the easiest way. You can create some subclasses, but will not use those subclasses. Let it be simple. Whenever we will create any class, we will create a separate file. Which error? No, then this is a compilation failure. You may have done some wrong thing. Okay, just copy this as, I mean, whatever I have written, including this semicolon and all. Okay. This is not error message, by the way. Okay, this is not error. Okay. Okay. Okay, fine. Any question on this? Class name should be same as this file name. Okay, so suppose this is I'm changing this class name. Okay, see, I am getting this error. So it should be same as the file name. See, program means a project. Okay, program means project. So what we have to do, a program or project may have multiple classes. Okay, for each and every classes we will create each and every files, Java files. We are creating a class means we are creating a Java file first and then class. Okay, because see, here is nothing, I mean, inside that file, only what we have to do is first we have to create this class, otherwise it's unusable. There is no meaning of creating this file. Okay, so everything is class and object in this in Java. So that is why Java is called object oriented programming language. Okay, just follow yesterday's class. Okay, just view watch the video of yesterday's class. It will be clear why Java is called object oriented programming. Okay, fine. So it's clear, right? Okay, any feedback? Any feedback? I'm going very fast. I'm going ideal. I'm going as per your expectation. Ah, yes, yes. Hmm. Fine. So from tomorrow we will deep dive into some fields. Field level means like I have created some variables, right? There could be some constructor. What is constructor? I will say I'll clear. I mean discuss. What are the methods? Right? Methods means what? Okay. Then we'll cover the data types, different data types. Like I have created, right? Integer data types, string data type, right? Those are all data type. Data means variables and constants, and type of the data means integer or string based on the memory location. Okay, where you want to store in the memory. So we have to put the type of the data. Okay, so those we'll discuss. And the next thing is what is there, interchanging of data types, which is called typecasting, which is very important. uh, Tomorrow we'll discuss those things. Okay, tomorrow we'll discuss those things, and bit of string concepts. Okay, what is string? So that will discuss, and after that we'll go to or move to object oriented programming language. Okay, so there are four things: inheritance, polymorphism, those things we'll cover. Abstraction, encapsulation, those things we'll cover. And then we'll cover all the statements and loops, statements and loop, like if, else statement, for loop, while loop. That will take time, maybe later this week, or starting of next week we'll cover. Okay, today is Tuesday, right? Hmm. So maybe by Friday we'll cover that loops and all. And next week we'll cover the advanced Java collection things, collection framework and all. Will the advanced things of core Java. Okay, these are all basic things. Basic. I mean, you should have this knowledge. You should have otherwise you cannot write a program. But if you want to tweak, if you want to get your grip on the programming, you have to have the collection framework knowledge. And if you want to clear all the interviews, right, you have to have this collection framework knowledge. Okay, that is one. And then we'll practice for one day some programming. Some programming means some logical problems we'll solve. Okay, like printing some pattern using loops and some logics, string manipulation means reversing string and all. Everything will do step by step. And then we'll close the core Java things. Okay, maybe 1.5 week we'll need to close all core Java things. Okay, then we'll move to Selenium automation framework, everything. But Java is most important throughout the training session. Whatever you will learn, this Java session is the most important thing. If you clear on Java, okay, then no one can stop you to learn automation. Automation is nothing but Java, right? Okay, fine. Yeah, thanks.